Now it's my favorite part, the ear. Now, before I was an anatomy teacher, I was actually an audiologist, which means I spent a lot of time studying the ear. And it's like my favorite time. And we smash it in with all these other special senses, and I don't get to talk about it very long. But okay. So here we go. All right. So the ear is cool because it gets two special senses. It gets the special sense of hearing and the special sense of equilibrium, which is your balance. And both of these are located in your ear, your inner ear, which is encased in the temporal bone. The stars of the show in both hearing and equilibrium are special receptor cells called hair cells. And they're called hair cells because they have long processes on them. They are cilia, but they are special because they are stacked, kind of like your cell phone bars. Okay, they're shorter ones to longer ones, and they actually have little tiny proteins in between that hold them together, so that if one moves, they all move. Okay, so and how they move is they bend. Okay, and if one bends, they're all going to bend in stereo. Okay, all together. So that's how they call it stereocilia. In the equilibrium area of the inner ear, there is an extra long one, really way longer. It's like cut off on this picture, way longer. It's called a kinocilium, which is an extra long cilium. Makes it longer and heavier. So it's going to take a different kind of stimulation in order to get it to bend. All right, taking a look at the ear, we can break it into three regions. We have the external ear, the middle ear, and the internal ear. And the external ear is everything from out here, the auricle or the pinna, it's also called, all the way down to your eardrum. Your eardrum is called the tympanic membrane. It is the border between the external ear and the middle ear. The external ear is all about catching sound. It's like a giant funnel that's going to catch sound waves, which are nothing but air molecules banging into one another, okay, and changing the pressure. And it catches those waves and funnels them and concentrates them down on this tympanic membrane. So it's a sound catcher. The middle ear, I want you to think of as a sound concentrator. Okay, we're going to catch those sound waves on this relatively big tympanic membrane, and we're going to change them from air pressure waves into mechanical waves, because anything that hits this drum will then move these three bones called the auditory ossicles, your smallest bones in your body. We'll move them, and they're going to change that, and they're going to push those waves into the fluid-filled inner ear. These bones, you do need to know their names. They are the malleus, the incus, and the stapes. The stapes is the smallest bone in the body. All of them together for a relative size comparison, in their configuration where they are right here in this illustration, this wouldn't stretch across a dime. Okay, they're that tiny. There is an opening here called the auditory tube, also called the pharyngotympanic tube. This goes out to your nasopharynx, and this allows pressure equalization between this chamber here and the outside air. If you've ever popped your ears, what you've done is you have opened this and allowed the air pressure to change, and the popping that you feel, or hear even, is just the movement of your eardrum. Normally, this should open when you yawn, when you swallow, when you forcefully open it, even when you scream, it opens. Okay, so now we're going to take all those sound waves that hit this relatively big eardrum, tympanic membrane, and we're going to concentrate them all down on this teeny tiny little end plate of the stapes. And stapes is also called the stirrup because it looks like a stirrup, and this end plate is where you would put your boot on the stirrup. And about 35 of these little stapes could fit on this eardrum. So we're getting a 35-to-1 concentration of those pressure waves. Can you hear without all this stuff? Sure. You're just going to hear a whole lot less than you would if we didn't have this sound concentrator device. Now, this is all fluid filled, and this area here is called the cochlea. Okay, it kind of looks like a conch shell. That's how it got its name. Those shells that you can hear the ocean in. Okay, they swirl round and round, kind of like a snail shell. And then this area over here, this large enlarged area with these 3 loops on it, okay, these are part of the equilibrium apparatus. Okay, and the loops are called semicircular canals. It's all the same fluid in here. Okay, it's all the same fluid, and now we're going to push that wave into this fluid, and the wave, just like putting a pebble into a lake and the ripples will propagate across the lake, that's how a pressure wave that we've pushed in here, a sound wave, will enter, and it will, like the ripples, it will go through all the fluid through this this cochlea, through this spiral organ. Okay, so this is a little closer look at that middle ear. We have ligaments holding those bones in place, as we do. We have 2 muscles in here too. The tensor tympani muscle, as its name implies, it tenses the tympanic membrane. Also, the smallest muscle in the body is called the stapedius muscle. It's the muscle that attaches to your smallest bone. It's going to pull on the stapes and tense that. Both of these muscles respond in response to loud sounds in order to protect your inner ear from transmitting such a loud sound into the inner ear. That is kind of an interesting concept because how did that develop? Because really the only loudest sound in nature to set that off would be a very loud clap of thunder. So we don't really know why. You know, it's not like they saw the iPod coming, right, with its loud sounds. We don't know why that developed. Okay, so the internal ear is actually a space in the bone. Okay, it's a hole in the bone that's lined with this membrane. It's not like we could take this out and lay it on the table, okay, for you. It's not an organ in that way. It's just this membrane that fills this space. All right, so the spiral-shaped organ is the cochlea, and over here we have the labyrinth mechanism, and it has these bulbous areas called the utricle and the saccule in them. Utricle is this one, the saccule is this one. No, you don't have to know which one's which, but then you do need to know that these loops are called these semicircular canals. These